Lesson 2 is on present value. It's just a slightly different arrangement of the formula for compound interest. So our formula for compound interest, we had the principal times 1 plus the interest to the exponent n. So what we were looking for with our compound interest formula was the final amount. That's what we didn't know. Present value is just the opposite. What we're going to not know is the principal that we're starting with. So an example of a question for compound interest would have been, Sam invests $2,000, and that's the principal, for 10 years, compounded monthly at 8%. How much will he have later on? So that's the final amount. When we're looking at present value, you have to be very careful when you read the question, because it'll say, Sam wants to have, so you're given this, Sam wants to have $10,000 in 6 years. How much should he invest now to have $10,000 in 6 years? So that's different. What we're going to be asking you to find is actually the principal. So that's how it's different. That's what present value is. Just first though, solving for the rate of interest. This is just a different example that you might see a question on this at some point. When John was born, his grandparents deposited $5,000 in an account that pays interest compounded quarterly. So all of those important key pieces of information. No further deposits or withdrawals were made. So it was a one-time deposit of $5,000. And then on John's 25th birthday, the amount of, so for 25 years, the amount in the account was $22,160.23. What was the rate of interest? So this is still a compound interest question. We already know the principal that they invested was $5,000. We actually know the final amount though that they ended up with. That was $22,160.23. What we don't know in this question is the interest rate. The N though, they invested for 25 years quarterly. So 25 times 4 is 100. So our N would be 100. If we just start for this question with our compound interest formula, either formula would work, but compound interest formula, we know the final amount. So that's the 22,160.23. We know the principal is $5,000, but we don't know the I, so that's unknown, and the N is 100. Okay, so we have to solve this equation for I, and this is just another question that you could be asked because it's just a slightly different way of looking at this formula. I think the very first thing I would see is that I could divide both sides by 5,000. Because if I did that, they would cancel on the right. So when I divide the left, I get 4.432. And then on the right, I only have 1 plus I to the exponent 100. Now, we have done exponents, and that's kind of why exponents came before this unit. I would take the 100th root, which you might think is kind of crazy, but I'm going to take the 100th root of the left side, 4.432, and I'm going to take the 100th root of the right side, 1 plus I, because what happens is I'm kind of canceling out the 100 values on the right side. The square root of something squared, they kind of cancel each other out. The 100th root to the exponent 100 would cancel each other out. So on the left I get 1.015 equals, this side I just have 1 plus I. Now I can move the 1 to the left, so 1.015 minus the 1.015 equals just the I, so I get 0.015 equals I. So the I would have been 0.015. But I want you to be careful there. Do you remember how this one was multiplied by 4? This I would have had to have been divided by 4. So we needed to find out how much the interest rate was from the beginning. So what we'd have to do is take 0.015 is really 1.5%, but we'd have to multiply that by 4 to kind of go backwards. So now we know that the interest rate must have been 6% per year. Okay, just a little different question that you might see. So you may want to put money aside for university or college, or something else that you want to buy in the future. You'd like to know how much you should invest now. So that's the difference. For present value, how much should I invest now so that I can make sure I have a certain amount of money in the future? To find present value, we're going to use the exact same formula for compound interest, but we just get the p by itself. So if I take 1 plus I to the n and divide it on the left, or divide both sides by that, I isolate the p. So this is the same formula, but just written in a different way. We're going to solve and find the principal to know how much we should have. If we know we want $20,000 later on, how much should we invest now to end up with that amount? So example 2, we have down the side, this time if I write pain down the side, which is, a lot of teachers would just kind of set these up first because I think it's a little bit easier. The P, we don't know the principal. An investment earns 5.75% compounded semi-annually. What's the present value of $900 5 years from now? So it's not a very big amount of money, but in the future, you would end up with $900. So we're going backwards. What we started with has to be less than that then, what we invested today. The interest rate, 0.0575, because it's 3/4, but I'd have to divide it by 2 because it's semi-annually, twice a year. So I get 0.02875. And then the n, it said 5 years. Semi-annually though, so I get 10. So just our slightly different looking formula, the principal is equal to the final amount divided by 1 plus I to the exponent n. So our final amount is $900, not that exciting. How much did we need to invest now to get that in 5 years? So 1 plus our interest rate, 0.2875 to the exponent 10. So I tend to usually just do one thing at a time. Some calculators are really awesome. You could type in 900 divided by bracket 1 plus 0.02875 bracket to the exponent 10. Type it all in at once and it would probably work out just fine. I usually just follow BEDMAS. I'd probably do this 1 plus 0.02875 first to the exponent 10 and get that number. I don't know, I just tend to do things in steps so I don't make a mistake. And then I have those two numbers and I could just divide them. And I get 677.87. So therefore, the present value is 677.87. Okay. Last example, Trisha has $1,500 in her bank account. She wants to buy a new bike now and invest the remainder at 6.5% compounded monthly for 4 years. At the end of 4 years, Trisha wants that $1,500 still to be in her bank account. Approximately how much can Trisha spend on a bike? So she wants $1,500 in 4 years. How much can she spend now? So the principal, we don't know how much she should invest now. The final amount, though, she wants to have that $1,500 when she's done. The I, it's 6.5%, so 0.065. Divided by 12 because it's monthly. Now, I get into a lot of decimals. You're going to see some of the work I do. I try and show my answers and how I get them, but this is going to look a little silly. 0.054166667. So what I've noticed is that answers in the textbook, and especially when we're talking about money, people want to be as accurate as they can. The more decimal places you leave in your answer as you go, the more accurate your final answer is going to be. So one thing, if you don't want to do that, 4 times 12, 4 years monthly is 48. So if you don't want to do that and write that, you could just leave this value written like that in your formula and then type it all in later. I don't know. I just think it makes more sense where the numbers come from if I show you what the decimals are. But you could just, instead of an I, you could write in 0.065 divided by 12 in a bracket. And that could be your I. And just kind of leave it like that until you're finally punching it in to get the answer on your calculator. So if we want to find the present value, the final amount that she wants to have is $1,500. And here I go with my decimals. I don't know. 0.054166667. And then that is to the exponent 48. Okay, so I would probably do the denominator first. You could type it all in at once if you wanted, but I would probably do the denominator first, add those two numbers up on my calculator, find the answer to the exponent 48, and I got 1.296. So if I have that and I divide, I get 1,157.41. So that's how much she'd have to invest now, but she already has $1,500. She could actually spend $342.59 on a bike. So if she just took this money here from her bank account and put that into her investment that pays, 6.5% compounded monthly for 4 years, by the end of that 4 years, she should be back up to the $1,500 that she had to begin with.